Assalamualaikum and hi. Today I will present or discuss about the question and answer. I hope you can spend your time to watch my video until end. Before we start, I will introduce myself first at the next slide. Section A. Express the unit vector directed toward the origin from an arbitrary point on the line described by x equal to 0 and y equal to 3. First step that we need to do is we need to plot this point. And after we plot, we can get that the point had on the YZ plane. So, from this, we can find the new point from P point to origin point. PO equal to O minus P, which is 0, 0, 0 minus 0, 3, z. We use z because we do not know the value of z. So, we can get the answer is 0, negative 3, negative z. After that, we can calculate the vector of u, which is 0ax plus negative 3ay plus negative zaz. And we can get negative 3ay minus zaz. Next, we need to calculate the magnitude of vector, which is square root of negative 3 square plus negative z square. And we can get square root of 9 plus z square. We know that unit vector formula is u equal to vector divided with magnitude of vector. We have the value of vectors and also the value for the magnitude. So, the answer that we can get is negative 3ay minus zaz divided with square root of 9 plus z square. And this is the answer. Section B. Find the distance between 2 pi over 6, 0 and 1 pi 2 where the points are given in cylindrical coordinates. These coordinates was given in rho, phi and z. When we need to find the distance, we need to change the cylindrical coordinate to the Cartesian coordinate, which is x, y, z. We assume that this point is r1 and this point is r2. For the r1, x equal to r cos phi equal to 2 cos pi over 6, and we can get 1.7321. Y equal to r sin phi equal to 2 sin pi over 6, and we can get 1. And z, we can get 0. Next, for r2, x equal to r cos phi equal to 1 cos pi, and we can get negative 1. Y equal to r sin phi equal to 1 sin pi, and we can get 0. And z, we can get 2. This formula, you can refer to the appendix. After we know the coordinate for the r1 and r2 in the Cartesian coordinate, so we can find the distance. P square equal to r2 minus r1, which is x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. And we put the value that we had calculated before this, and we can get d square equal to 12.4643 and d equal to square root of 12.4643, and the final answer we can get 3.53. Next is the second question for the section B. Find the distance between 1 pi over 4 0 and 1 3 pi over 4 pi where the points are given in spherical coordinates. You know that this coordinates was in the spherical coordinates, which is r, theta and phi. So, we need to change it into the Cartesian coordinate. We assume that this one is r1 and this one is r2. So, for the r1, x equal to r sin theta cos phi equal to 1 sin pi over 4 cos 0, and we can get 0.7071. Y equal to r sin theta sin phi equal to 1 sin pi over 4 sin 0, and we can get 0. Z equal to r cos theta equal to 1 cos 0, and we can get 1. Next is for r2. X equal to r sin theta cos phi equal to 1 sin 3 pi over 4 cos pi, and we can get negative 0.7071. Y equal to r sin theta sin phi equal to 1 sin 3 pi over 4 sin pi, and we can get 0. Next, z equal to r cos theta equal to 1 cos 3 pi over 4, and we can get negative 0.7071. After we know the R1 and R2 coordinate in the Cartesian coordinate, so we can find the distance. D square equal to R2 minus R1, which is x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. And we insert the value that we calculate before this, and we can get d square equal to 4.9142, d equal to square root of 4.9142, and we can get the last answer is 2.22. Section C. Show the electric field E outside a spherical shell of uniform charge density is the same as E due to the total charge on the shell located at the center. So, this question use Gauss law equation. First of all, we need to calculate the electric field outside the spherical shell, which is the region shell. We know that in the Gauss law equation, we have Q enclosed equal to integration of d ds. We also know electric flux density is D equal to epsilon naught E. So we can change D with epsilon naught E. So we can get Q enclosed equal to integration of epsilon naught E ds. And we rearrange the formula and we can get Q enclosed over epsilon naught equal to integration of E ds. Next, we solve this one first. To solve this, we will make E as a constant and then we can integrate ds. Integrate ds, we can get 4 pi r squared. So the final answer is E 4 pi r squared. Next, we need to know the volume of shell. We know that the volume of spherical is 4 over 3 pi r squared. So from this, we can calculate the volume of shell, which is 4 over 3 pi r square r2 minus 4 over 3 pi r square r1. And we can get 4 over 3 pi r2 cube minus 4 over 3 pi r1 cube. We need to simplify and we can get 4 over 3 pi r2 cube minus r1 cube. In the Gauss law, we also have the formula Q enclosed equal to integration of rho v dv. So rho v as a constant and we integrate the dv. So we can get rho vv. We have the value of v, which is this one, and the final answer for Q enclosed equal to rho v 4 over 3 pi r2 cube minus r1 cube. Back to the first equation, which is Q enclosed over epsilon naught equal to integration of E ds. Know that the value of Q enclosed is this one, and E we have this one before, and then we can get rho v 4 over 3 pi r2 cube minus r1 cube over epsilon naught equal to E 4 pi r squared. We rearrange and we can get rho v 4 over 3 pi r2 cube minus r1 cube divided with 4 pi r squared epsilon naught. We simplify and we can get E equal to rho v r2 cube minus r1 cube divided with 3r squared epsilon naught. And this is the electric field for the outside spherical shell. Next, we need to find the electric field at the center of spherical shell. We know that electric field formula is E equal to integration of rho v dv over 4 pi epsilon naught r squared ar. Ar is a vector and we can ignore it. After we integrate, we can get rho vv over 4 pi epsilon naught r squared ar. And we also have the value of v, so we can get rho v 4 over 3 pi r2 cube minus r1 cube divided with 4 pi epsilon naught r squared ar. We simplify and we can get rho v r2 cube minus r1 cube over 3 pi epsilon naught r squared ar. We know that the electric field at the center of spherical shell is same with the electric field at the outside of spherical shell. Section D. Find the charge enclosed in the volume of R, V, and Z given the charge density rho equal to 2Z sine square. We know that the volume that given was in the cylindrical coordinates. Charge enclosed formula is Q enclosed equal to integration of rho v dv. dv is the volume of the cylindrical coordinate. Volume of cylindrical coordinate is rho d rho d phi dz. So we can put the information into the formula, which is we can get Q enclosed equal to integration of 0 to 2, 0 to pi over 3, 1 to 3, 2z sine square phi rho d phi dz. And then we need to integrate all of this. To avoid the mistake, we can integrate 1 by 1. First, we integrate d rho. Q enclosed equal to integration of 1 until 3 rho d rho. When we integrate rho, we can get rho square over 2. Insert the value of this and we can get 4. Next, we integrate of dz. Q enclosed equal to integration 0 to 2 2z dz. When we integrate 2z, we can get 2z square over 2. And we can simplify this one. We can get z square. Insert this value and we can get 4. Last one is we integrate the dv. Q enclosed equal to integration 0 to pi over 3 sine square phi dv. First, we need to change sine square phi into 1 minus cos 2 phi over 2. We put 1 over 2 outside the integration and we can get 1 over 2 integration of 0 to pi over 3, 1 minus cos 2 phi dv. And then we integrate 1 minus cos 2 phi dv and we can get 1 over 2 times with phi minus sine 2 phi over 2, and then insert this value into this one and you can get 1 over 2 0.6142 and the final answer is 0.3071. Don't forget to combine all the integration value, which is Q enclosed equal to 4 times with 0.3071 times with 4, and the final answer for this question is 4.9136. Section E. Given A equal to 5 sin theta A theta plus 5 sin phi A phi, find delta A at 0.5 pi over 4 and pi over 4. We know that the information was given in the spherical coordinates. So, the formula for the delta A in the spherical coordinate is this one. Then we need to put the information into the formula. AR, we don't have the information of AR, so we assume as 0. A theta, we have the formula of A theta, which is 5 sin theta. And then we can write 5 sin theta sin theta. A phi, we have the information of A phi, which is 5 sin phi, so we can write 5 sin phi. After that, we can simplify it, and it will be 1 over r sin theta d 5 sin square theta d theta plus 1 over r sin theta d 5 sin phi over d phi. After that, we differentiate this one and also this one, and we can get 1 over r sin theta tan sin theta cos theta plus 1 over r sin theta phi cos phi. Sin theta and sin theta will be eliminated, and the last answer we can get tan cos theta over r plus 5 cos phi over r sin theta. So that we need to solve the A theta at a point 0.5 pi over 4 pi over 4. 0.5 is r, pi over 4 is theta, and pi over 4 is phi. We put this point into the formula and we can get tan cos pi over 4 over 0.5 plus 5 cos pi over 4 divided with 0.5 sin pi over 4. We can get 14.14 to 1 plus 10, and the final answer is 24.14 to 1. Section F. Given the field E equal to negative 16 over r squared in the spherical coordinates, find the potential of point 2m pi pi over 2 with respect to 4m0 pi. The equipotential surface are concentric spherical shell. Let r equal to 2m be A and r equal to 4m be B. We know that the relationship between the electric field and the potential is E equal to negative delta V. We can rearrange the formula and we can get ER equal to negative dV over dr. V equal to negative integration of ER dr. We have the value of ER, which is this one, and we can get negative integration negative 16 over r squared dr. Negative will be positive, and the v equal to integration of 16 over r squared dr. Then we need to find the potential between this point and this point. Will be VAB equal to integration of a to b 16 over r squared dr. So a is 2 and b is 4. We can get integration 2 to 4 16 r to the power of negative 2 dr. We integrate this one, we can get negative 16 over r, and input this value into this one, and we can get negative 4 plus 8, and the final answer is 4. Section G. Find the number of conduction electrons in 1 meter cube of copper if sigma equal to 50 ams over m and mu is 3.2 times 10 to the power of negative 3. On the average, how many electrons is this per atom? The atomic weight is 63.54 and the density is 8.96 times 10 to the power of 3 kilogram per meter cube. We can use the formula of sigma equal to NE mu. E is the electron value. We have the value of sigma and E and mu. So we don't have the value of N. So we can get the N. So N equal to sigma over E mu, which is 58 times 10 to the power of 6 divided with 1.602 times 10 to the power of negative 19 times with 3.2 times 10 to the power of negative 3, and we can get the N value is 1.1314 times 10 to the power of 29 electrons per meter cube. Number of conduction electron is NV. V is the volume of the cube of copper. To find the volume cube of copper is V equal to 1 times 1 times 1, and we can get 1. So we can get 1.1314 times 10 to the power of 29 times with 1, and we can get number of conduction electrons is 1.1314 times 10 to the power of 29 electrons. Next step, we need to find the number of atoms, but we don't have the mass value, so we need to find the mass value first. From the rho equal to m over v, and we rearrange the formula, we can get m equal to rho v and equal to 8.96 times 10 to the power of 3 times with 1, and we can get mass of the cube of copper is 8.96 times 10 to the power of 3 kilogram. And we change the atomic mass, we can get 0.06354 kilogram per mole. We can find the number of atoms, which is equal to mass over atomic mass times with Avogadro numbers. And then we can get 8.96 times 10 to the power of 3 divided with 0.06354 times with 6.022 times 10 to the power of 33, and we can get number of atoms is 8.4918 times 10 to the power of 28 atoms. And then when we have the number of conduction electron and also the number of atoms, we can find the electron per atom, which is number of conduction electron divided with number of atoms. We can get 1.1314 times 10 to the power of 29 over 8.4918 times 10 to the power of 28, and the final answer we can get 1.33. Thank you for spending your time to watch my video. Have a nice day and see you again.